Example 5.2.1. Setup for this one says you would like to take a trip over spring break but are short on cash. You estimate the trip's cost at $2,000. You have three options to finance the trip. First, you could put it on your credit card, which has an APR of 12% and requires monthly payments, which is 12 payments per year, of course. Second, you could take out an online personal loan with an APR of 12% that requires quarterly payments, which that should say 4 payments per year. Once per quarter or once every 3 months would be 4 times per year. Finally, your parents offered to lend you the money at an APR of 12% and are comfortable with semi-annual payments or 2 payments per year. Semi-annual means twice per year, so every 6 months. You plan to repay the loan over the next 12 months no matter which option you choose. Which financing option offers the lowest effective interest rate? Okay, so the calculations will end up being pretty simple on this one, but it's getting at an important conceptual idea, and that is the difference between an annual percentage rate and an effective rate. By law, all loans in the US and in much of the rest of the world are required to be reported as an APR annual percentage rate, and an annual percentage rate is the interest paid per year without the effects of compounding. And as we saw in Chapter 3 and especially Chapter 4, if we add a number of periods to a problem that involves cash flows earning or paying interest over time, the more periods we add, the stronger the effect of compound interest gets, and the stronger it gets every single year. It grows at an exponential rate. So if we were to ignore the effects of compounding, we could greatly underestimate, in this case, the cost of a loan. So all three of these have the exact same APR, but they have different frequencies of payments or different compounding periods. The first one on the credit card requires 12 payments per year, so every time you make a payment, there's a little bit more interest due, and then the next payment you make has a little more interest on interest. It's compounding every time you make a payment, so every month there's a little more compound interest. The online loan is only having you make payments 4 times per year, quarterly payments, and so since there are fewer payments being made, there's less compound interest accumulating within that year, over that time period. And then your parents, of course, have the fewest number of payments, just twice per year. You're only going to make 2 payments on that one. So there's fewer opportunities for compound interest to accumulate. So outside of class, when we run into these different loan offers or different investment offers, it's important to consider the frequency of the cash flows and account for the effect of compound interest so that we can kind of compare apples to apples, right? If we have 2 different cash flow streams where the cash flows are happening with different timing, then we need to be able to convert to an effective rate to compare those 2 things. Like an APR is just not going to capture the true effective rate unless we're looking at a problem where there's only 1 payment per year. Then there's no compounding period happening within the year, and so the APR and the effective rate are one and the same. And that was the case all through Chapter 3 and 4. Since we were dealing with just annual cash flows, there was no need to worry about whether we were looking at an annual percentage rate or an effective annual rate. The 2 are equivalent in that case. We've got just 1 payment per year. Now that we're here, we need to be able to convert to an effective rate to compare these guys. And this is a time value of money problem. We're looking at cash flows over time, and we're asked to solve for an effective rate. We can sidestep the 3-step process for this one, though, because there's a formula that gets straight at the conversion from an annual percentage rate to an effective annual rate, which is what we're going to convert to. And there's also a calculator function that we'll look at after we use the formulas. In fact, let's take a peek at our formula sheet real quick. If I scroll down to the Chapter 5 formulas, we have a few here having to do with interest rates. One is the definition of APR, which is kind of baked into this problem, but we don't necessarily need it right here. The other one is the EAR, or effective annual rate, and it equals the APR divided by M, where M is the number of compounding periods per year, and then raised to the M minus 1. So APR is what we're given, and then this M is the number of compounding periods, or when we're looking at a loan, the number of payments per year. And this ought to look kind of familiar, right? This APR divided by M, if we take the annual rate and divide it by the number of payments we're making per year, we're going to get the effective rate that matches the frequency of cash flows. So for example, if we have a monthly payment like we do on our credit card, we take that APR and divide it by 12 because we've got 12 payments per year, 12 compounding periods per year. We're going to get the monthly effective rate. That'll plug in right here for APR over M. So we've got 1 plus an interest rate raised to the number of compounding periods. Now that looks an awful lot like our interest rate factor that we looked at in Chapter 3 that allowed us to compound cash flows over time and account for that compound interest. And this is in fact serving the exact same purpose. It is capturing the effect of compound interest, in this case within the year instead of over a period of years. But it is exactly the same concept. So we're just going to take this formula and plug in the information that we've got and convert each one of our APRs to an effective annual rate so we can compare the effective rates instead of the stated rates that are ignoring compound interest. So let's look at these one at a time. Option 1 is the credit card. And with the credit card, we have a 12% APR and monthly payments. So we'll write out our effective annual rate formula. We've got 1 plus the APR divided by M, which is the number of compounding periods per year, raised to the M, minus 1. So our effective annual rate on the credit card option is 1 plus an APR of 12 converted to a decimal, which we need to convert it to a decimal because we're going to do math with it instead of plug it into the calculator. So converted to a decimal, 12% is 0.12, divided by M, the number of compounding periods per year. In this case, that's 12. We're making monthly payments. There are 12 months per year, so there are 12 compounding periods on that loan. And then raised again to the M, which is the number of compounding periods, again 12, minus 1. All right, 0.12 or 0.12 divided by 12 is going to be 0.01. All right, and now this 0.01, which is 0.12 divided by 12, it's important to realize what this guy is, or to think about what this guy is. Since we've got monthly payments, when we take that APR and divide it by the number of months or number of compounding periods, what we have just found is the monthly effective rate on this loan. So we are paying 1% per month on this loan. And in fact, that's how APR is determined. The credit card company decides that you're going to pay 1% per month, and then they have to report the annual percentage rate to you. So they'll take that APR of 1% per month and multiply it by the number of payments per year to get the 12% that they report to you. But as we're going to see in just a second, that ignores some big effects of compounding and underreports the effective rate that you're actually paying on your credit card. Okay, so let's plug that into the calculator. We've got 1 plus 0.01, which is 1.01. We need to raise that to the 12. So if I'm using the BA2 plus, I'm going to press the Y to the X key and then enter 12 and then press equals to have it do that calculation. And then we still need to subtract 1. This one equals. All right, so our EAR is 0.1268, which is in decimal form. As a percentage, that is 12.68%. All right, so although the credit card statement that you receive in the mail will say, hey, you're paying an interest rate of 12%, that's your APR, you are effectively paying 12.68% every time you make a purchase on that credit card and let it accrue interest over time. Right? So that's darn near a full percentage point higher than what it's actually reporting. So it's important to account for those effects. Okay, let's look at option 2. Option 2 was the online loan. And that was also a 12% APR. And it had quarterly payments. All right, we're going to use our EAR formula again, where EAR is equal to 1 plus the APR divided by the number of compounding periods, raised to the number of compounding periods minus 1. All right, everything's going to be the same here except the number of compounding periods. It's still going to be 1 plus 0.12. Now we're making quarterly payments, which means 4 payments per year. So our M is going to be 4 in this case. All right, 0.12 divided by 4. 12 divided by 4 is 3. Of course, we've got the decimal there, so that's going to be 0.03 raised to the 4 minus 1. Now that 0.03 is 3%, and that 3% is the effective quarterly rate. Right? So it's the effective rate that matches the frequency of the cash flows that are happening on this loan. All right, let's plug that into the calculator and see what we get. 1 plus 0.03 is 1.03. Want to raise that to the 4, so y to the x. 4 equals, and then minus 1. Okay, so as a decimal, the effective annual rate is 1255, or 12.55%. Right, so the effective rate on this online loan that we're taking out is about 12.5%, which is a little bit better than the 12.7% that we were looking at with the credit card. So a little bit cheaper there. All right, let's look at option 3, which was the loan from our parents. That one also had a 12% APR, but with semi-annual payments. All right, we'll plug into our EAR formula. 1 plus the APR over the number of compounding periods, raised to the number of compounding periods. And once again, everything's going to be the same except the number of compounding periods. Our APR is still 12% or 0.12. M in this case with semi-annual payments, that means twice per year, so we're only going to divide 12 by 2 in this case. $12 divided by 2 is 6. We've got the decimal there, so it's 0.06. All right, and that 6% that we just calculated is the effective rate that matches the frequency of the payments. So that is 6% every 6 months, or 6% every half year. Okay, so let's plug that in and see what our effective annual rate is. 1 plus 0.06 is 1.06. We need to raise that to the 2. So I'll press y to the x 2, and then subtract 1, so minus 1. As a decimal, the EAR is 0.1236, or 12.36%. All right, now we've got the effective annual rate for each of these 3 options, and the effective annual rate is the rate of interest paid per year that includes the effects of compounding. So this is the true rate expressed on an annual basis for each of these loans, and once we've accounted for the effects of compounding, we can actually compare these guys. So, loan from our parents has an effective annual rate of 12.36%. The loan from the online personal loan that we could take out is 12.55% effective annual rate, and the loan from our parents is 12.6, or I'm sorry, the loan from the credit card is 12.68%. Okay, so these actually worked out to be in descending order, and it turns out in this case that the loan from our parents is the cheapest option, so that's what we would take in this particular example if we were looking for the cheapest option. Of course, whether the relationship with your parents is worth navigating to do this, or you might want to just pay a little bit more interest per year. That of course is completely up to you, but this is the lowest priced option. Okay, there's two other things that we should talk about. Let's do the calculator first, because there is a tool on the BA2 Plus that will allow you to jump back and forth between an annual percentage rate and an effective annual rate relatively quickly. This is a pretty simple formula to navigate, so I'm not sure this saves a lot of time, but it is a tool that's there, so I want to make sure that you're exposed to it. Okay, and the tool we're going to look at is iConvert, ICONV, which is right over the number 2 key. So the way we access it is we start by hitting the second key, and then press iConvert, which is right over the number 2 key. And there are 3 entries in this little worksheet that opens up. There's NOM, which stands for nominal rate. Nominal means in name, so that's the stated rate. In this case, that's the APR, annual percentage rate. It's the one we're given. There's also EFF, which is the effective rate, or the effective annual rate in this case. And then there's C over Y, which is the number of compounding periods per year. And the way we move between those 3 is just by using the arrow keys. You can use the up or down arrow keys, and it'll just move between those 3. So NOM is what we're given. Let's calculate the effective rate of the credit card to begin with. It's a 12% APR with monthly payments. So our nominal rate is 12. It's a memory function just like the others, so I've already worked this problem recently. It's still stored in there, but we're going to enter it as if we're working it for the first time. So to enter 12 for the nominal rate, I type in 12 and press enter to store it. I'm going to calculate the effective annual rate, which is, if I hit the down arrow key, it'll take me the effective rate, but I still need to enter the number of compounding periods per year before I can do that. So I'm going to press the up arrow, which will take me to C over Y, or the compounding periods per year. For the credit card, it's monthly payments, 12 payments per year. So I want to enter 12 and press enter to store it. And I want to go back to the effective rate. So you can either hit the up arrow key or the down arrow key twice. Just hit whatever one you want until you get to EFF. And then you can hit compute on the top left, and it will take the nominal rate and the number of compounding periods per year. It'll work through the effective annual rate formula and give you the actual effective annual rate, which is 12.68, which is exactly what we got here. Now let's do one that wasn't already in there. That's the online loan with quarterly payments. In this case, the APR is still 12%. The only thing that changes is the number of compounding periods per year, which is 4. So I'm just going to hit the arrow keys until I get to C over Y, or compounding periods per year, and I want to change this 12 to 4. To do that, I'll press 4 and then hit enter. And I want to get back to the effective rate using the arrow keys. And once I'm on the effective rate, it still says 12.68, but that's because it was calculated from the previous entries. I haven't asked it to recompute it using the new number of compounding periods per year. To do that, I'll hit the compute key, and it'll recalculate that effective annual rate using 4 compounding periods per year, and we'll get that same 12.55% that we got using the formula. We can do the same thing for the semi-annual payment loan from our parents. Again, the only thing that changes is C over Y, so I'm going to navigate to C over Y and change it to 2, get back to the effective annual rate and hit compute, and we'll get that same 12.36%. All right, the second thing that's worth mentioning is before we can compare these loans, before we can compare either an investment or a loan based on the interest rate, we need to make sure that the interest rate is expressed over the same time period. right? So if we have cash flows that are happening with different frequencies, some are monthly, some are quarterly, some are annual, we need to take the interest rate associated with those cash flows and convert them all to the same. Now, we could convert them all to monthly, we could convert them all to quarterly. It doesn't really matter as long as they're all in the same terms. By convention, especially given the way APR is computed, we typically will convert it to an effective annual rate and just compare the effective annual rate. There's not necessarily magic there. We could use the effective monthly rate, the effective quarterly rate, and what have you, but there would just be more steps involved in calculating it in most cases, and so we tend to compare the effective annual rate of different options in order to make sure that we're capturing all of the true costs associated with these different loans or the benefits when it comes to an investment.